All right, the last type of factoring we're going to talk about is factoring by grouping. So factoring by grouping, once again, is one you can do when you have 4 or more terms. And usually 4 terms is what we're going to see with this. And you can see here this format. That's not exactly what we're going to see because we're dealing with polynomials with one variable, right? Polynomials of one variable. And so instead of having like 2 different sets of variables, what we're going to have is something like this. It ends up being, like what a quadratic ends up being factored out, except instead of having like x, plus a number, x minus a number, you might have like x squared plus 3 and x plus 2 or something like that, let's say. Okay. And so just to show you what you're going to end up with is x squared times x, which is x cubed, x squared times 2, which is 2x squared, 3 times x, which is 3x, and 3 times 2, which is 6. All right. And so that's basically what it'll look like, right? And then we don't have any like terms anymore like we usually do because we had different variables here or different variable expressions. All right. Now the way factoring by grouping works is what we're going to do is we're going to group these first 2 together and these second 2 together. And we're going to factor out the GCF between each of those or from each of those. And so for example, the GCF between x cubed and 2x squared is x squared, right? And then we put our leftovers back inside. So our leftovers would be x plus 2, right? And I'm going to do the same thing here. I'm going to factor out the GCF. I'll do it in a different color. The GCF between 3x and 6 is 3. Here's one key point is whatever sign this is, that's going to be the sign that you want to make sure you factor out. So if that's a negative, make sure you factor out a negative. But in this case, it's positive, so I'm going to factor out a 3. And then I'm going to put the leftovers back inside. And if I divide both of these by 3, I'll get x plus 2, right? So notice how now we have a match, right? X plus 2, x plus 2. And that's actually a common factor, right? Because this whole binomial is a factor. This whole binomial is a factor. So I can actually factor that whole binomial out to the front. And then I can put the leftovers back inside. And the leftovers would be x squared plus 3. Right? And if you notice, that's what we start out with. Different order, right? The order was swapped, but that's okay because commutative property works with multiplication. A times B is the same as B times A, right? So that's how we do factoring by grouping.